Welcome to Around the Drafting Table, where we talk about topics that are top of mind for homeowners looking to design a new home. I am Kory Cox, the Oxford architect. Our topic today is structural engineering, another member of the design team on your custom home journey, who can be the difference between an efficient design and expensive solutions. Joining us today, we have creative structural engineer Chris Reeves from Epic Engineering. Chris, thank you for joining us today.
Yeah, thanks for letting me talk to you.
To begin, would you like to briefly talk about your experience and how Epic Engineering tackles high-end custom home design differently from other typologies that you work on?
Sure thing. I've been with Epic for a little under 7 years now. We do a lot of custom homes. In fact, that for the first 5 years was almost all I did.
Mhm.
Um, and it's a very interesting thing to be doing because there's no regularity to it. It's very non-repetitive, and you get to be somewhat creative and design interesting and beautiful things. It's
Mhm.
it's a lot of fun working on custom homes, but it can be quite challenging. From a structural standpoint, they're very similar um, in their purpose to other structures. They're an above ground artificial cave. Um, but how we tackle them is we set our expectations at different levels. The quality might be higher, the budget might be higher, there might be more irregularity and weirdness and oddness, um, so it's just the way I approach it is essentially just with a different set of expectations
Mhm.
uh, to produce something unique. And that's the approach I take. And that means that every single project is a little bit different, and there's no set path. It's just generally keeping an open mind and willing to
Yeah.
work with.
I mean that idea that every project is unique and has new challenges is what keeps me coming back for more. And I hope that that's how we deliver quality to all of our homeowners. They're looking for something unique. They want a statement piece so they can, enjoy themselves and show off to all their friends and family. So, tell us about a custom home project that you've worked on recently. Can you share any project details or outcomes?
Yeah, sure. I'm working on one right now it's not the most unique structure. It's pretty straightforward, but it's a very high altitude, so high snow loads. So
Hmm.
there's some interesting design challenges with that. It does look nice, but it's fairly regular. But I have within the last 2 months submitted to other custom homes that were actually quite irregular. One had very, very large cantilevers, and the customer wanted concrete deck, this cantilevered concrete deck, some other weird little things like a very tall stairway right at the edge with a lot of glass. And then the other house I'm working on, it was actually constructed more like an office building or a high rise where we had concrete slabs and just all the structural all the structural skeleton was steel. And then the exterior skin was built not like a curtain wall system hanging, but built on these concrete shells that we detailed out. So it was a very unique home design and highly irregular, but because of the systems we used, that is steel and concrete, we were able to do it without much of a problem, something that we couldn't have done based out of wood.
Yeah.
The outcomes, they came out a bit more expensive, obviously, because we're using the steel and concrete and dealing with possible tariff situations and things like that.
Hmm.
It make the project eventually more expensive. But from a design perspective, they all came out pretty well.
Nice. So, with the concrete and steel one, was the architect expressing those elements throughout the design, or was it kind of hidden beneath the surface?
They are expressed. They're
Okay.
all visible elements. You can see the concrete, you can see parts of the steel. There's a bridge built into the building. It was part of his design intent.
Okay, perfect. So for that one, it's very much from the beginning, we understand we're going to use this other structural system, might be more expensive, but we're showing it off everywhere. It is part of the aesthetic that the owner wants, and that helps us achieve our goals in the end.
Yes.
Great. What would you say are the highest priorities in structural design in homes?
Okay, so in AEC, architectural engineering and contracting, we all have different goals, obviously, and are trying to work together.
Hmm.
The ultimate goal being to satisfy the client's needs. From the structural engineering standpoint, my number one priority is safety. I put that above all other requirements, and I work with the other disciplines like architecture and contracting to satisfy the other priorities, but my number one is safety.
Yeah.
I want to make sure that the structure is either standing after a design level event, that is an earthquake or a windstorm, your 5,000 years or your 100-year storms, 5,000-year earthquake, 100-year storms,
Hmm.
or that it's standing long enough for you to get out of its safety. That is the number one priority for me as a structural engineer.
Yeah.
You safe. I mentioned an artificial above ground cave earlier.
Hmm.
That's how we structural engineers view buildings. We're trying to protect you from the elements, from other people, from predators, whatever.
Yeah. It's an interesting concept, and I think it's important for owners to understand because we don't talk about this a lot. The building code is not intended to save structures. It's intended to save lives.
Exactly.
Yeah, I mean, it's the same when I do fire safety design. In most cases, we're not interested in saving the structure. We're interested in keeping the structure up just long enough for everyone to get out. And if an owner is interested in saving the structure, there's been a lot of conversation lately about the like the fires in LA and what fire safety and home design can mean in fire-prone areas. There's a lot we can do to protect structures, but it's sort of above and beyond the building code, and it's the same with structure.
Exactly. There is, we do bring this up with clients for these higher end jobs that the code is calibrated toward the level we call life safety. Again, just
Hmm.
protecting lives. The structure can take a ton of damage.
Yeah.
But then there's also, there are different levels in different parts of, like, say, the concrete code, not
Hmm.
the normal concrete code, but the retrofit rehabilitation code, where you can design for higher levels where, like, immediate occupancy after an earthquake or a storm,
Hmm.
something like that. You can design higher. The code minimum is life safety, and designing higher will cost more, obviously.
Yeah, I've worked on a couple of buildings like that in the past. I worked on an emergency operations center for train operations in Los Angeles. And that one, I think the structure was designed such that 10% of the columns could be knocked out by earthquake, explosive device, whatever, and the building would still stand.
Hmm.
I worked in a hospital as well that was very similar, where, the understanding was if there is a major earthquake or similar event, the hospital needs to be functional the next day so that it can serve the needs of the community in its time of need.
Yeah, we can address that in multiple ways through something called risk category design directly in the code,
Hmm.
or again, a customer can specify. It's like we have our design minimums,
Yeah.
but the customer can tell us, look, I want you to design for not Salt Lake City's maximum earthquake. I want you to design for more than that, or I
Hmm.
want you to design for this, that, and the other. As long as you're above and beyond the minimums, you can specify anything you want.
Yeah.
Um,
I think it's interesting to talk about sort of why we don't design buildings to last through just any possible event. I was having a conversation with a bridge engineer a number of years ago, and he talked about it this way. He's like, when we design a bridge, we design it either for an earthquake or to be fully laid in. Imagine a bridge with, just elephants marking across it, 100 elephants, just like packed tightly together, or just heavily laden trucks, like very, very heavy. That bridge is going to support that load, but it will not support that load if there's also an earthquake at the same time. And
yep.
the reason for that is because the chances of both occurring at the same time are astronomically low. And if we did so, the cost to build everything would just go up exponentially.
Exactly. So we often talk about safety margins and errors, or maybe you've watched like television shows like Star Trek or whatever. It's like I'm operating at 100% of design tolerance, or I'm above 150% of design tolerance. That's
Hmm.
actually in real life like 150%. How can that work? We statistically we set our expectations through experience and statistics. A lot of
Hmm.
statistical analysis saying this is the probable capacity of an object, and this is the probable demand of the object. And then we establish acceptable failure criterion, and we overlap them. Because if you think about probability, um, there's a very small probability that anything could happen, but
Hmm.
it's very small. So there's no way by the nature of the universe and statistics that we can predict everything, and that therefore we must accept some level of risk and uncertainty. So when we establish the codes and various design levels, we establish that acceptable level of risk and reliability and how long we want something to last at a bare minimum or the expectation of failure. And then we calibrate our what we need versus what we can provide.
Hmm.
Um, but if you're trying to eliminate all forms of risk, things become impossibly expensive. Like
Yeah.
you can't build something if you don't have the money for it.
Hmm.
So you just have to accept the fact that I can't design a 100-story skyscraper in New York City expecting it to be hit by jet aircraft. That is something
Yeah.
outside of what a structural engineer would consider. Or I can't design a house for a meteor or something like that.
Right.
So uh, we just cannot design a building to withstand everything in the universe. It's just too expensive.
Yep. Everything is a compromise in design.
Yeah.
What challenges do you regularly face on high-end custom homes, and how do you overcome?
So the biggest challenges in a high-end custom home is by far the roof. Um,
Hmm.
Roof design is the most. I've heard people who work on skyscrapers saying that they prefer working on their 100-story regular skyscrapers than they do a single residential roof. They're just They're highly irregular. They've got crazy shapes. Sometimes they're vaulted, sometimes they're not. The roofs are just, it takes a lot of time to design them.
Yeah.
And then touching on that, it's mostly because of irregularity. The next big thing is irregular floor layouts, where bearing walls are not in line, or lateral serving elements are not in line, where things are just, um, yeah, there's no planned regularity to it. So it makes it very
Hmm.
hard to design and follow what we call the load path. That is
Yeah.
getting load successfully from point A to point B, where B is the foundation.
Right.
Um,
And A
so
is the roof, right? It's vertical loads that
yeah,
we're talking about here.
yeah. And we also do load pathing for lateral as well.
Yeah,
But
and we're going to talk about lateral in a bit.
yeah.
But I do want to talk a bit more about something you said there about kind of stacking things vertically,
Hmm.
right? So you have the roof on the top, and then you might have a wall, and then if you have a wall directly underneath that, that's a direct load path, and that's efficient and inexpensive, right?
Very.
So when we have to move walls for for purposes of the floor plan, for space planning in that level below, how do you handle that to transfer the load path
We
over and
generally
then down?
we have what we call transfer beams under them,
Hmm.
that are responsible for carrying all the weight above it. And then we move it to other beams or columns that are inside other walls we want to use.
Hmm.
So the act of moving a wall that's holding up, like say a roof or a bunch of floor over 2 feet, all of a sudden you've gone from a stud wall to a possibly very large steel beam. Um,
Yes.
so those
And that depends on
irregular,
the span and the magnitude of the load, etc. But
exactly.
essentially what you're talking about is you have the roof up here, you have the wall, and then it comes to a beam that goes to 2 points like that. So you're kind of building a little bridge for
Yeah.
that upper wall to sit on.
Yep.
And then
Exactly.
that will go down to the footings below.
And we do that. I do that all the time in custom
Hmm.
homes because there's so many irregular walls, and trying to find the places to hide the columns to try and still be structurally efficient takes a lot of time. So
Yep.
irregular floor plans and irregular roof plans are the biggest challenges, but essentially it's just figuring out where to hide the columns that fit with the architect's vision and make sure that we try and stay within size limits. Every once in a while, we actually do have to work with the architect to make some adjustments.
Yeah.
If like, look, I can make this work, but I need an 18-inch deep beam and that's going to stick out of your floor. Are you fine with that? So
Right.
we do have to
Yeah.
work back and forth sometimes.
Hmm. Yeah, there are a lot of challenges to deal with there. I was working on a home a couple of years ago where the basement had, kind of an open recreation room that was, 20 feet wide or so. But we had these loads coming down, coming to the middle of the ceiling. So we had this giant beam, and I think it was, like a 24-inch deep steel beam to support that load, just so we could avoid having a column in the middle of the room, which was really important to the owners.
Hmm. Yeah. Yeah, that happens all the time.
Yeah. We do try in designs to find ways of bringing those paths down as directly on top of each other as possible to limit those transfer beams and create an efficient structural package, but it's not always possible. And it just
Yeah.
depends on what's most important to the owner, whether it's bits of the layout or if they want to try and save money and keep steel out of the building.
Yeah, absolutely. I remember quite clearly that actually being in practice, it makes so much more sense. But so statics is one of the very first classes we as a college student would take for
Hmm.
engineering. It's the physics of things at rest and forces, things like that. And I remember my professor saying, look, structurally, I can make a sports stadium infinitely more efficient by putting a column right in the center of the field because I'm basically having spans in every direction. But
Yeah.
it can no longer do its job.
Right.
So, I mean, if it can't do its job, you're not doing your job as a structural engineer. So you
Hmm.
still need to service the client's needs. So efficiency doesn't always equate to just structural efficiency and cost. It's a balance of use, what can we do, and materials, labor, other things like that. So it's all a
Yeah.
balance working with the client and the architect.
Perfect. When do you typically get involved in the design process, and would you prefer to be in the room earlier?
Sort of have to talk about contracting schemas in a little bit of way and project management.
Hmm.
There are several different ways on how we approach building different things in our society. The most common is what we call design bid build, where a client has a need for something, and they approach generally it's either an architect or a contractor to say, "Hey, I need this thing built," and then they design it. So in your case, the architect
Hmm.
works with the client to design something, and then they send it out for bid to the engineers and the contractors or whoever else they need to finish and realize this idea. And that's design, bid, build, and that's generally mostly how custom homes and private design works. Uh,
Hmm.
Other things like municipal, you might have heard of things called like um, design build, where do a little bit of design. This is like how I-15 was done back when we refurbished it for the Olympics to get ready for the Olympics, where
Yeah.
they designed the first little bit of it to say, okay, we've got enough to start on. The contractors can start building and doing their thing. And by the time they get to this point, we'll have the next portion designed. And that's
Hmm.
called design build, where you're designing as you build and go.
Right.
And that can be very efficient, but the thing is, you're just designing a sort of utilitarian structure at that point. You're designing something to be primarily used when if you're going for aesthetic or something like that, it's not very efficient because you need to really think through these high-end, beautiful designs. It's really good for producing something that works.
Yeah.
And since we're part of design bid build, I'm usually last one of the party. Basically, it's me and MEP and plumbing, where the architect has already been working with the owner for weeks, if not months, to get this design ready. And the owner has funding together. They've got a plot picked out. They've got everything done. And now they're like, here's some drawings, make it work.
Hmm.
That isn't the unfortunate reality, but I would prefer to be the most efficient designs. It's going to have a higher upfront cost, but could generally save a lot of long-term costs if myself and the builder are actually in the room with the architect when they're working with the owner for designing. So we can identify, hey, we can do that. This might be a little cheaper just to do this. Move this column over 6 inches. Can we get this wall over here a little bit?
Hmm.
Can we do this, that, or maybe give you ideas or maybe optimize things early on because changes later on in the project life become more expensive.
Yeah.
So
Very, very true. So what you're talking about, making small incremental changes, move this wall 6 inches, this column 6 inches. That's something that we do a lot of in design development, which would be the kind of fourth phase of design. So you mentioned two things that I want to talk about. So the first is owners already have a site picked out. And the second is schematic design is already done, right?
Mhm.
So what advice might you give to owners on site selection?
Do your due diligence and research. First off, the county surveyor has the records of all the surveys that we've essentially ever done because property and land ownership is one of the biggest things in the United States. We've got records going
Mhm.
back several hundred years.
I mean, I recommend to all my clients that before a site is chosen, that we work with a realtor to look at a lot of those things you were just talking about, and then B, an architect to look at it from an architectural perspective. But the third thing that I think is probably more relevant to structures is a soils report,
Hmm.
right? Because depending on what soils you have on site and the slope of the site, that's going to be a survey. So you'll have kind of like a geotechnical report, which is the soils, and then a survey, which is going to give you the geometry of the site. So you work with both those elements to determine what structural system can actually be used on the site, correct?
So a geotechnical report, depending on the size and scope of the report for a residential lot and the amount of testing you want done, can
Hmm.
range anywhere from $500 to $5,000. But it's important to note that if the structural engineer doesn't have this information, then we have to go off of worst case presumptive values as specified in the code, which usually results in a what we call a conservative design. That means we're over designing to cover our bases.
Right.
So
And
I
that's going to cost you a
recommend,
lot more than 500 bucks.
yeah, yeah. So for that reason, I always recommend for anybody designing a custom home, get a geotech,
Hmm.
because the possible savings on the soil characteristics could easily offset it. Plus, if there's anything wrong with the site, you'll find out early that you need to address. And
Yeah.
the soils report can tell you a lot, good or bad, but you have to build your house upon a rock. It has to be on a solid
Hmm.
foundation. If the soils fail, your building's failing.
Yeah, exactly. And this is something that should be done ideally before the land is purchased, not after.
Exactly.
So it is an upfront investment for an owner who's looking at a piece of land, and the land could be hundreds of thousands or many millions of dollars. So you do this minor investment of a few thousand, do the geotechnical report, we can review it, and then if we find anything of concern, it might be something that tells the owner, don't buy this land. This land is going to be a challenge. It's going to cost you too much to build on top of it because of issues that are not immediately apparent, that are kind of beneath the visible surface.
Yeah, it's sort of like when you're buying a home, there's that like contingency thing you've got where it's like, we'll do this contingent on what comes back from the house, the building inspection or whatever. Uh,
Hmm.
Getting that into the contract, like contingent on a geotechnical or survey, isn't a bad idea.
Yeah. It's never perfect, of course. I was working on a hospital project a number of years ago. Obviously, they had done geotechnical, right? But when they do that, they don't excavate the entire site. They just do little core samples here and there. And there was a foundation of an old building buried beneath the site, and nobody had any idea that it was there. So we got into excavation, we ran into this foundation, and we just had to spend hundreds of thousands of dollars removing it to make room for the new foundation. And that's an example of an unknown condition, which is why contingency is so important.
Yeah, for sure. So we don't have that problem as much with custom homes. They have a much
Hmm.
smaller building imprint. So one or two cores will usually give you a decent idea of just what's under what you're going to build.
Yeah,
Um, but those bigger buildings, yeah, you need a lot more cores to try and accurately characterize the soils.
yeah. Okay, so in our previous part of the conversation, we are talking about when you want to be involved in the design process. That's talking about site selection. Moving forward, then into schematic design. And our entire conversation today is kind of about what owners should be concerned about with structures in schematic design. But if you were to boil it down, what would you say are the important elements to think about if you get involved in that phase of design?
Think of it this way. The structural engineer is designing the skeleton of the building. The skeleton of the building, like if you look at a skyscraper, the building is like 95, 99% air. And the structural skeleton is just this flimsy steel things. If you
Hmm.
think about your house the same way. It's like, yes, you have bearing walls and you can see all these walls. If you turn those walls, you only put important columns where you need to. You can create a lot of irregular shapes around a regular skeleton.
Hmm.
So if you plan in a certain amount of regularity so the structure has a good amount of load path without too much transferring, that's the, and if you can nail that early, you can hide the regularity inside that shell of whatever beauty or weirdness you want to do around it. So it's just kind of strategic planning of, look, I do want a bearing wall here, and I want to
Hmm.
track this bearing wall down so I can maybe modify the floor plan below to sort of hide or distract from that continuous path to make it more interesting or whatever. Just planning ahead and thinking about the load path.
Right.
That's the earliest thing we can do for efficiency and saving, trying to save money.
Okay, perfect.